So the last one, find the complex power delivered by the dependent source. So let's do some nodal analysis. I'll call that V0 and I'll call that V1. So at V0, you can make that ground. I'll have V0 minus 24 over 4 plus V0 over 1 plus V0 minus V1 over minus J1 equals 0. So that's 1/4 V0 minus 24 plus V0 plus, so 1 over minus J, if I multiply that by J over J, that's J over negative 1, that's just J. J times V0 minus V1 equals 0. So 1/4 V0 minus 6 plus V0 plus JV0 minus JV1 equals 0. So V0 1/4 plus J plus, wait, I had another V0 there, so V0 plus 1/4 V0 is 5/4 plus J plus negative JV1 equals 6. I think that's right. Okay, and then at V1, I have V1 minus V0 over minus J plus V1 over J2, and then minus 2V0 equals 0. So that's 1 over minus J is J, so JV1 minus V0 plus 0.5 minus J V1, because 1 over J is minus J, minus 2V0 equals 0. So JV1 minus JV0 minus 0.5 JV1 minus 2V0 equals 0. So I have minus 2 minus J V0 plus 0.5 J V1 equals 0. I'm going to multiply through by, well, so that you'll see why I'm doing this. 0.5 JV1 equals 2 plus J V0, so I just brought that to the other side. Multiply through by 2, 2 times 0.5 is 1, so JV1 equals 4 plus 2J V0. And then divide by J, V1 equals, dividing by J, 1 over J is the same as minus J, so it's minus J times 4 plus 2J V0. So V1 equals minus J times 2J is minus 2J squared, which is plus 2, minus J4 V0. Right, and then I can plug that in, so I have V0 1.25 plus J plus minus J times 2 minus J4 V0 equals 6. So 1.25 V0 plus J V0 minus 2J V0 minus J times minus J4 is plus J squared 4, which is minus 4 V0 equals 0. So let's see, so minus 4 and plus 1.25 is 2.75, minus 2J plus J is minus J. V0 equals 6. V0, I put a 0 over there because I like to do that, but yeah, that's not really right. 2.75 minus J. Let's see, this back here, there should have been a minus 2.75. I think that's right. So minus 1.93 plus J, so minus 1.93 plus J 0.700. And what are we looking for? Complex power delivered by the dependent source. Okay, so if we look at our dependent source, we see that its voltage is V1 and the current is 2V0. So we have the current, we can get the voltage now. V1 is 2 minus J4 times minus 1.93 plus J 0.700. Take our last answer times 2 minus J4. And I get V1 is minus 1.05 plus J 9.10. Alright, and alright, and so now okay, so now my complex power will equal 1/2 V I conjugate, which will be 1/2, and the V I just found, minus 1.93 times 0.7. And then I conjugate is, so I is 2v0, and so I conjugate will be 2v0 conjugate, so minus 1.93 minus j.700. So the 1/2 and the 2's cancel, and that will just equal the magnitude of one of those things squared. And notice that because these things were complex conjugates of each other, I end up with a real answer. So I get 4.21 dA.